Okay, well, welcome. This is another in the series of EuCAPT interviews with members of the EuCAPT community, where we try and find a little bit about them and what they think about the field at the moment. And today we're very happy to have Professor Pedro Ferreira with us, who's going to give us his insights into life and physics. So welcome, Pedro. So maybe you can start just by telling us a little bit about where you're from originally and what your background is.
So I'm from Portugal. I'm from Lisbon. I was brought up in Lisbon. I spent a little bit of time in the UK when I was young, but mostly I was brought up in Lisbon, and I did my undergraduate there. I did engineering.
Yes, that's very interesting. We'll come back to that. But you sound very English. I mean, you say that you spent a little bit of time in the UK. Can you say something in Portuguese? Maybe you can say, I'm professor of theoretical cosmology and astrophysics, just in Portuguese, just to prove to our listeners that you are, in fact.
Yeah. Sou professor de cosmologia teórica e astrofísica.
Okay, I don't know if that's right, but I'm going to assume that it is.
I just made that up.
Portuguese people will judge for themselves.
Yeah.
Okay. So yeah, tell us a little about this. So you actually did engineering as your undergraduate degree. So how did you ending up in physics?
Well, I did engineering not because I wanted to do engineering, but there was this folklore when I was growing up that the best schools were law, engineering, and medicine. And so you kind of wanted to go to one of those. I wanted to do physics. And I was convinced by my elders that you should do physics in engineering school. And it turns out that Técnico, which is where I did my degree, had just created a course called Physics Engineering, which was on the one hand an idea of recruiting people who are interested in physics who wouldn't otherwise apply to Technique, and on the other hand, an idea of bringing in lots of bits of engineering into one degree. And so I ended up there. But I always wanted to do physics, and actually, the moment I got in, what I really wanted to do was maths and physics.
But did you ever find any of your engineering knowledge useful in your subsequent career, or have you really been channeled into the physics side?
The thing is, I don't know if as a curiosity mostly. I mean, we did wonderful things. This was the 80s, where I remember having 2 lecture courses on digital systems, where we learnt to build that the kind of the end point was we learnt to build, I forget which microcomputer or which computer, the PDP-11 or something like that, from scratch. And I've forgotten it all. But I think it's cool to have done that in the past.
Yeah. So how did you make the transition into physics? Was it difficult to then change direction after you'd done your degree?
So no. So there were a lot of very good physicists at Technique, and a lot of particle physicists and some GR people. And so I was very much taken by that. I was actually mostly seduced by mathematics. We had the people there was this young cohort of faculty members who had done PhDs mostly in the US, who were really gung-ho about teaching us maths. So I was very into maths. By the end of my degree, it was a 5-year degree, I wanted to do quantum gravity. So I applied abroad to do quantum gravity, and I ended up at Imperial. And at Imperial, I started my PhD on quantum gravity working with Chris Isham. And this was at the beginning of loop quantum gravity and Ashtekar variables. And I worked on that stuff for a few months. And I realized that it was very interesting, but I also felt that it was professional suicide. And so, more importantly than that, this was the year that the Kobe results came out. And I was exposed to these people who were cosmologists who I didn't really know very much about. And I realized, God, this is really exciting. And so Andy Albrecht had moved to Imperial at the time, and Neil Turok were around. And they were, I think they were in their early 30s, and they're just so exciting that I just shifted fields and started working in cosmology. And I think I made a good decision because I think I've been privileged to be part of the whole, I mean, really the exciting golden age of cosmology.
You mean with cosmology becoming a kind of a precision science as
Yeah,
opposed to something a bit more sort of hand wavy?
exactly. I mean, the 1980s and 70s, but the 1980s, it was, as I think Mike Turner called it, the gold rush, because people were just making stuff up, and it was so exciting. And you had all these links to particle physics, and but it was all made up, right? There was no real data. And then all of a sudden, with COBE and APM, the APM Survey of Galaxies, and IRAS 1 I mean, all these things, you start to actually begin to constrain things. So it's almost like the precision age of cosmology came about a decade later in the late 90s, early 2000s.
Right.
But I would say that the 90s were great because it was on the cusp where you had nothing and then you had something. And so it was more like discovery. You look at, for example, cosmic microwave background, and George Eustathiou and Dick Bond in 1987 predict what they think the angular power spectrum of the cosmic microwave background is going to look like. And it's this beautiful paper, but it's hard work, and it's these peaks and troughs, right? And through the 90s, you're kind of looking for that. And then you find it. You come to 99 and 2000, and you see the peaks and troughs, and it's just so exciting.
Is that the most exciting thing that you've had in your career? Is there something, what is that the most exciting moment, or has there been another moment that you would consider as exciting?
I think that's probably the most exciting thing. I was lucky because I'm a theorist, but I for a bit I almost did an apprenticeship working with experimentalists during one of my postdocs. And I got involved with these two experiments, which were Maxima and Boomerang. And until in my view, until Maxima and Boomerang published their results, what you had was a scatter of measurements which kind of traced a bit of the angular power spectrum, and then another experiment which traced another bit. But you had uncertainties in the calibrations, and then Maxima and Boomerang come along, and you just have one map for Boomerang and one map for Maxima, and you can calculate the angular power spectrum, and it just sweeps over that bump. And the thing is, I remember sitting in my office and having this map and just taking the Fourier transform of it, and just calculating the power spectrum and just seeing it go up and down. And I mean, that's priceless.
Yeah. So how has your research focus evolved over time? So you sort of have you sort of always worked in the same stuff on cosmology? I think sort of later in your career, you've taken on a lot more things. Can you tell us a bit about that?
I can. So I started off by working on cosmic strings. And the thing that I was interested in with cosmic strings was cosmic strings as a theory for structure formation. And so in the late 80s and early 90s, there were really two rival theories. There for a theory of structure formation. There was cosmic strings and there was inflation. And the reason that people worked on cosmic strings or topological defects is because in some sense, in principle, they're more predictive. You only had an energy scale, and then all the rest was nonlinear dynamics that would lead it. It's just very difficult to calculate with, and it still is very difficult to calculate with. And so I worked on that for a bit. And through that, I learned a bit about the cosmic microwave background and started working on the cosmic microwave background because, again, I was swept up by the COBE generation. I'm definitely from the COBE generation. Then I did my first postdoc at Berkeley, where I became more interested in the cosmic microwave background. And that's where I decided to, on the one hand, I did various things. I worked on non-Gaussianity in CMB, but also the mechanics of extracting science from a CMB experiment, from time series to maps to angular power spectrum to parameter estimation. And so I did, for a number of years, that was really what I learned to do. And it was great because you could do it on your laptop. You could construct these things, or not on your laptop, but on your desktop. And then you had some bits of data and you could try it out. And I did that. And again, that worked out very well for me because I was involved with Maxima and Boomerang. And this all came out in around 2000, which is when I moved to Oxford. And then my interests broadened, and so around the same time, I was also interested in early universe, or trying to link. I mean, the thing that I've always found interesting is what can we learn about fundamental physics from cosmological observations. And so that was the angle of topological defects in large-scale structure towards the end of the 90s, before the supernova measurements. With my friend and collaborator Michael Joyce, we worked out how scalar fields could affect the growth of structure at late times, and that was great because we worked out the perturbation theory and all of that just before dark energy, and so the papers that we wrote have been very useful for quite a few people in figuring out how to work perturbations in dark energy models. I've always had that strand, and that strand became quite important amongst. I worked on many things in the 2000s, but amongst others, the key thing that it started to emerge towards the end of the 2000s is my interest in constraining general relativity with large-scale structure, and that kind of dominated my life for a number of years. And the idea is that by looking at, for example, how the evolution of gravitational collapse and the way that lensing behaves and all these things, you might say something about what gravity is doing on very large scales. And again, I've been lucky because that has become kind of one of the core science goals of future surveys. And and in doing that, I shifted more to looking at structure formation and less at CMB. So I haven't worked on CMB for a number of years, and I mostly work on clustering, and so that has dominated a lot of what I've done.
So what would you say is the most sort of important open question in your field? What for you is the sort of the key question that still remains open?
Okay, so I'm just going to parrot what everyone says because I think it's true, which is there are three big questions that link cosmology to fundamental physics, which is what is dark matter, what is dark energy, and how did the universe begin? And that how did the universe begin can be rephrased as, what is the inflaton, if we believe in inflation, but I think it's a more general thing. So those are the big questions.
And how do you rate our sort of chances of answering those in the next sort of decade or so?
My view on that has changed in that I think, so, I mean, the reason that we think we can link fundamental physics to cosmology is very much a consequence of the euphoria of the 60s and 70s in particle physics, where we made such huge progress in figuring out the standard model. And around that time, people started to think we could do the same with cosmology, because in principle, we could make measurements which could tell us something about fundamental physics. But that has set a really high standard. That means that we think that solving those questions means figuring out what are the fundamental fields that are the dark matter, the dark energy, and the inflaton. Okay, and so a way of thinking about it is, we can write down the action for the standard model, and we would like to add in these extra terms, which are for the dark energy, dark matter, and the inflaton. And I think we've set that standard too high. I just don't think we're going to do that. And I don't, to be honest, I don't think we're going to do that ever, unless we find some completely different way of looking at these things. So, for example, if a particular type of dark matter detector picks up an axion with a mass of whatever,
right?
Okay, that's good. But from looking at large-scale structure, the usual tools of cosmology are not going to give us that. Which is not to say that I don't believe they exist. I do think dark energy, dark matter are out there. I mean, inflaton, I'm a bit on the wall with that one. And that we know how to describe them incredibly well. I mean, if you look at the model, the current model, the lambda CDM model, I mean, it fits the data beautifully. I mean, there are some anomalies in which we have to explore and understand. But the bottom line is, I mean, even these anomalies, I think, are percent level discrepancies, which might create some problems and might create some tweaks. But I think that we've got a model, we've got a mathematical model for dark energy, and we have a mathematical model for dark matter, which works very well. And it's just not the type of maths that we would like to have. We would like to have an action, but we don't have an action. We have some phenomenological models. So
Yeah, I guess it depends what you mean by knowing what they are, right? I mean, I guess, science is not about truth at some level. It's just about having a good model, as you say. Okay, so you actually wrote a book about gravity, about GR, called The Perfect Theory. How did you find writing it, and would you do it again? Do you plan to write another book?
So that was a book. I have a very dear friend who's an agent, and he said you should write a book, and I said, well, it's a lot of work. And but talking to him, I realized I've always liked GR, and I've always asked people about GR, and I've been very lucky that I've gone through these places where I've had very articulate people telling me about GR, like I go to Oxford where I've got Penrose, and I met Dennis Sharma years ago. I was in Austin, which had all these amazing people. I was at Imperial where I remember talking to Chris Isham about quantum gravity. I've been lucky to hear these different things. So I thought I'm kind of a GR groupie, so why don't I write a GR groupie book? And so I wrote this book, which is a biography of GR, and it's which was great. For one reason is I read a ton of papers that I would never read. I didn't know anything about AGNs and black hole accretion. I didn't really know much about the history of gravitational waves, all these things, and I read all these things, and so scientifically it helped me a lot writing the book. But I wrote that book, and it was, it took up quite a bit of my time. I had to do it after hours, but it took up quite a bit of my time. When I write another one, I'd have to find a topic which was as engaging as that one. I wouldn't write a book just to write a book.
Right.
So I'm still looking for a topic.
Okay. All right. Suggestions on a postcard to Pedro at Oxford University. Okay. Tell us what do you like and dislike about being a scientist?
What I like is the freedom. What I like is this bizarre thing that it's like being a poet or an artist. That is how we work. People often think of scientists as people who are assigned problems to solve. And so they've got this duty to solve these problems. And that's not what drives us. What drives us is God, that's really cool. Let me try this out. Let me figure this out. And it's it's that hackneyed statement that you basically look for problems. Being a scientist is not solving them, it's looking for them. And I absolutely love that. I love that that's what you do. On the other hand, the downside is you're defined by how well you do that. And so you if you go off and do some fringe thing that you really like but which is kind of completely irrelevant, that's what you've done. And you're responsible for having made those choices. And
do you still feel like that now? You still feel under pressure to sort of perform and to sort of do amazing things, even sort of when you're professor at Oxford?
I think you'll never stop feeling that. I think the other thing is there's something that actually develops in your old age, which is
you're not that old, Pedro.
I know, but it makes you feel actually responsible, because when you start seeing all these talks about stuff which is kind of interesting, but it's really of interest to the person who's talking about it, a bit self-indulgent and doesn't really address the big questions, you think, wow, is this what people should be doing? And so there is something about age which you would think makes you more carefree, but I don't think it makes you feel okay.
Do you feel responsible for sort of setting the trends, and then
you've got people there's this lecture by Feynman describing physics in which he compares certain aspects to cargo cult. And so the Feynman thing was that you can have all these rituals that you think you're doing science, and you're producing papers and you're giving talks, but actually if you then look at it, you're not making any progress whatsoever in the understanding of the world. And so, what are you actually doing? So that's my worry is that. And so I think I've become more sensitive to that as I've grown older.
Okay.
The other thing is, the downside is, it's this well documented thing, which is most scientists in our fields peak at a younger age, right? And
Ah.
and so that hunger and that ability to do a calculation, a hard calculation, or write a code, which just you need to drill down, and you just need to be single-minded and go through, and just that's your focus, and which I see in the amazing postdocs that we have here, that they have the ability to do that. I think most of us lose that as we grow older, because we have all these things to do, and we're running things, but also because we're just older.
But do you think it's just because, do you think it's not maybe necessarily age, but you're more comfortable? It's sort of easier.
It could be. I don't know. Maybe it may be, but I definitely feel it's an age thing. I definitely feel there's a physical aspect to it, a kind of a mental physical aspect to it. I mean, you do have what people say more wisdom, and so you do have a bigger view of the field, and how to. But the fun bit is the drilling down, and that's the thing you start to miss.
But then so this actually brings us on nicely to my next question, which is about what new skills are you currently learning, or are you planning to learn in the future? Because I think that you're someone who likes to sort of pick up new skills and new areas. So can you tell us a bit about that?
So new skills. So there's the meta question, and then there's the specifics to do with science. So with science, I've tried. It just has happened that every, I don't know, 7 years, or I've worked in something slightly different. And so when you and I started working together, I had just started working on gravitational waves and black holes, and I have to say I've enjoyed tremendously working on that stuff with you. And I think that stuff is relevant. I mean, I really enjoyed it. And that's the same. You could go back and 7 years before that is when I started working on testing gravity with cosmology, and that whole program for me. And more recently, and a much less effective way, I've become interested, like everyone else on the planet, in machine learning. And so, and again, it's it's very hard to make a significant contribution when you enter something which is just so active and so but you try and find what you want to do. So that would be the answer in terms of interests, scientific interests. I don't know what are in terms of new skills, for example, leading. I mean, I've been leading the Beecroft Institute for 15 years now, and it almost works like a commune, Right?
Is that a good positive comment? Or?
I think it is. I like it. I like it that way. I don't like telling people what to do. And in fact, I love the way that we're all constantly able to fill this with really good postdocs. And they all have the initiative, and that's what runs it. It's not like there's no top-downness about what's going on here. So maybe I should learn some leadership skills, but at the moment
you don't want to be a lead. You don't want to be a leader. Is that what you're saying?
Yeah, I don't feel a great need. If I'm thrown some administrative role, then maybe I should brush up on some leadership skills. But at the moment, so no, I don't know what new skills I would like to learn
in life, just only in science.
Exactly.
Okay. Since we're on sort of more general questions about life, let me ask you, what do you do to relax after a period of do you ever relax, Pedro? I'm not sure if you do, but if you do, what do you do to relax?
I don't relax a lot because I've got quite a few children, and so I move from.
Are they not relaxing?
They're fantastic, but they're not relaxing. No. They are absolutely fabulous, and but I wouldn't at all consider that relaxing.
So they take up all your spare time.
I mean, the only thing I do is I run every day, and I find that a nice half an hour a day where I'm listening to an audiobook, and and I don't even know if I enjoy running, but it's definitely something that I need to do.
What audiobooks do you listen to? Do you listen to science or?
So my cocktail of audiobooks is, I'd say 1 in 4 is a crime novel. And then another one is a big book. It's like homework. So, in the summer or just before the summer, I finally read Moby Dick.
Okay. Yeah.
And before that, it was Dostoevsky's The Idiot, and so I always try to intersperse with that. I will do a science book, but it's got to be the right. I'm not a huge fan of pop sci, but every now and then I will get one, like one on CRISPR or something like that.
Yeah.
And then all these, a bunch of novels that I should have read and I had never read before. So, for example, I'm listening to Laurie Lee's I Walked Out One Midsummer or something like that, which is it's very beautiful. It's about him leaving his village and walking all the way to Spain.
Oh, that does sound quite relaxing. And so you do find a little bit of time to relax then.
Yes.
So Pedro, you're a great mentor to early career researchers like me. So would you have any advice to either your younger self or to other sort of colleagues who are just starting out in the field? What would you tell them?
And I think anything that I would say would be very unoriginal. I think
it's okay to be unoriginal.
I mean, I think you've got to like what you're doing. I think you've really got to like what you're doing. I think you have to dive into what you're doing. Can't do it half-heartedly, otherwise you won't really get the full reward of doing what you're doing. And yeah, I think those are the two things, which is you've got to like it and you've got to do it hard. You've got to put in the effort.
So if you could go back to your younger self, there's nothing that you would change or tell yourself to do differently. You would just say, work hard.
Well, the thing is, I think I did work quite hard then. And so, I really did work quite hard during my early years. And it just makes you, I think it makes you feel happier and better about what you're doing if you felt that you've really been so immersed in a problem that you, I don't know, it's almost like an endorphin thing. That's the bit that's the good bit about doing science.
Yeah.
Because I think that goes away as you grow older, and it's taken away from you as you grow older because you get more responsibilities. So I think that's the key advice, is just make the most of that initial period of just because you will reap the rewards from doing that and you'll enjoy it.
Okay, that's good advice. So how I guess a lot of people would ask about for younger or earlier career researchers, one of the main questions is, how can I stay in academia? How can I find a job? It's quite competitive. Do you have any advice for how you go forward in your career? I mean, apart from just really enjoying what you're doing and doing a good job of it, are there any sort of broader things that people should think about?
I don't think I've got foolproof, ways. I don't think I've got advice along the lines of, if you do this, you'll be fine. I just don't have that, because I've, as you say, I've mentored a lot of people, and many of them have done very well, but others who I think are equally good haven't. And so, and I think there is a fundamental element of luck / unfairness in many aspects, where you get a job, the topic that you work on taking off or not. Whether people notice you. It's just, I'm constantly floored by how some people are just noticed and then they just take up, and other people who I think are fantastic just never get the traction. And I think the key thing is just not to let that get to you. And I think the other thing that I've become more and more aware of is what we call the real world, which is jobs outside academia, is so interesting.
Mm.
So the thing that I want to say is that everyone I know who has left academia has been super happy. Super happy. They've ended up in these really interesting jobs, be it in finance, machine learning, data science, anything like that. They've all been super happy. And so I almost feel like, do not let the fact that if you are not making it in academia, that you feel that it's a personal failure, because it's not. It's just there are all these elements that make that happen, but more that there are more routes than academia. And I think it's really important to notice that.
I think it's important, for your own sort of confidence to say, I'm worth a lot in, as you say, in the real world. We always use this phrase, in the real world, in like in physics. We are in the real world too, right? Okay, well, thank you very much, Pedro. That's been a really interesting conversation, and I hope that our listeners find it equally interesting. So thank you again, and for everyone watching, please tune in for our next EuCAPT interview. Thank you.